So as I promised yesterday when we're doing the Sapphire X4000, it's a Grandstand Gemini today, which is Wednesday. So start can do every other Wednesday morning for CB, as I'm now no longer doing the elderly lady. As she's 94, she's now needing professional care, as I was doing some shopping for her. So that kind of 3-hour slot can now be taken up every fortnight with CB radios instead. So I've printed off the instruction book just in case I can't remember how to work a Grandstand Gemini. It's nice for people to see this. I had the sense at the time in 81 to photocopy every instruction book that came through, and that's now, well, it's not financial, but it's reaping the benefits for completeness of what I've got. Now, it came with a circuit diagram in the back, and they were scanned at a better rate recently. So we've got that, and I've made some notes from that circuit diagram as to what I'm doing, because you've got several mixers in these, and it's difficult to get them right on receive especially. It's come with a Shogun microphone, which I think is a shame because, mind you, mics might out-survive the Shoguns because they were suffering from dry joints even within the first year they were made. So they are very, very troublesome dry joint-wise. And it's come with the 5-pin DIN of the dreadful type, which is another shame. So, to be honest, that would be, if that was mine, that would be getting a 5-pin communications plug put on it and get put on one side for a Shogun, and this would get a generic mic. I'm going to show you what the real mic should look like, because you may see them for next to nothing on eBay. Now I'll just pause the video. Well, that was easier to find than I thought, because one of the sets on my to-do shelf of my own is a Grandstand Gemini. That is the microphone, and that is the plastic factory moulded plug. So it's still nasty. We would use the metal ones if we were putting one on. So it looks like those awful power mics, but it isn't an awful power mic. It's a made in Japan Grandstand mic. So you'll see this labelled as Grandstand Wagner, that's spelt with a W, and also Atron, A-T-R-O-N. So any of those are these type of mics. So if it's the power mic type, it's got a horrible thumb wheel for its horrible power micness. It's a good word. So you know what? I think we'll repair this set with my mic. That's a special treat. And we'll put his mic on one side, but make sure it's compatible at the end. So there we are. It's like it's wider than most sets. It takes up some real estate in your car. Other versions using this chassis, apart from the Atron and the Wagner, you'll also see the Telecoms. Is it TC9000, which comes in 2 versions with a cell core socket on it. Now, when these were made in 1981, nearly every semiconductor in these is NEC, as in Nippon Electric Company, not National Exhibition Centre at Birmingham. NEC is Nippon Electric Company, and nearly every semiconductor is one of those. So inside here, the synthesizer was already 3 years obsolete when these were made, and I reckon that Saruga, who made these, must have been sat on a bucket load of UPD2812C synthesizers, which I think are used in a Royce American product. It's a general purpose synthesizer. It requires separate crystals. I'm not going to do this. This is a trade repair. That's up to the supplier. And the importers were, of course, Beware at Harrogate. And so we've got, there we are, the Grandstand. They were all unusual sets. And you've got DINs, which suits me. I love DINs, there you go. But it can be a bit of a snag for people who need to make up an adapter lead. And that's the best thing to do, make up an adapter lead. I did say I was going to show the extension speaker type we use, and I'll dig one of those out. While I don't talk into the microphone, I will dig one out. And I also want to show an oscilloscope. We're going to use, I get people repeatedly asking how we connect the oscilloscope to do the detector. So I'm going to use one of these cheap £16.99 oscilloscope kits to show that, rather than use a normal oscilloscope. I may as well use one of those. It's just connected across the extension speaker, but we'll come into that. The first thing I'm going to have to do is take the lids off. Just be aware, if you buy the Atron version, it's a conversion of a Dutch set, which would have started life as 22 channel 2 watts or half a watt, whatever they were doing at the time, and they got officially converted for the UK market, but they can be even more troublesome than these already are troublesome. Now, these are good sets when they're working, but they're unreliable, like the Shogun's unreliable, because I've taken the bottom lid off, because they are riddled with dry joints. So it's a double-sided board, it's not plated through, and it relies on component leads a lot of the time to make the second connection on the other side of the board. And it has an enormous IF and synthesizer can here, which is filled with wax. So I've said to the customer here that I'm taking no responsibility for any dry joints. We'll service the set, and that's it, because they are riddled with dry joints, which is a shame. Now, if you're using one of these sets, and I say they work very well, if you're using one of these sets, anybody who is talking on a radio where the deviation is too high will chop, because they don't have crystal filters, but the ceramic filters and the extra stages in these sets are such that anybody who isn't pinpoint on frequency or pinpoint under 2.5 kilohertz deviation will chop. And so, whereas a Fidelity 1000, everybody will sound great on it. And of course they're made by great, aren't they? There wasn't any pun intended there. But of course the selectivity on those is exceptionally poor. The selectivity is excellent, and so anybody operating off frequency on an illegal radio, anything like that, will come through on this abysmally. That's great, because you know they've got a dodgy radio, don't you? I'm on a Grandstand Gemini and you've got a dodgy radio. So some people get the impression I dislike these. I don't dislike them at all. I think they're fantastic sets, but they're unreliable. So I don't want to see loads of them coming in for service, or we'd have to actually concoct a special tariff, which will be considerably higher than normal. So, without any further preamble, we will connect this up to our famous crocodile clip leads, which we will try not to short out. See, that's an easy fix, to put another piece of lead in there, inline fuse holder. I don't know. So I've switched it on at 13.8 volts. We know it powers up. I'll connect it to the test equipment. We won't connect it to the speaker because I haven't got a DIN adapter. I don't think. I'll have to get more crocodile clips on it. So there we go. I've already shorted the power supply out. That's going to continue. So switch it on. You don't need a mic for it to receive. And we will actually try and remember to switch picture in pictures on today. And it's there. Wow. So we're going to transmit. It's doing 3 watts. Quick look at deviation. Wow. It's within limits. The AGC is a bit funny on these. It peaked at over 3 initially, then it came down to 2.5. So that's fair enough. What else can we say? Let's just see what the receive's like. And it's I know this is where they're struggling. So I'm just going to set the signal generator up for channel 20, 2779125. I'll switch the cyanide meter on, we'll show that on the screen. I'll have to put a crocodile clip onto the input lead for that. I think we should just have to connect the inner. There we are. Right, so we'll get that for 12. Just make sure the RF gain's somewhere. Oh, it's not full. So that's more or less on 12. So we'll go to the attenuators, and this radio is doing, we're on 10 scale, it's doing 4.2 microvolts for 12 decibel cyanide. So it's pretty deaf. I'll make some notes on the back of here. It's doing 3 watts. It's doing 4.2 microvolts for 12 dB cyanide. The supplying dealer says this was a dead set and he got it working by sorting out the voltage regulator, which is fine. Deviation was 2.5 kilohertz. It's more or less there. We'll just see how on frequency it is. I'll take this with a bit of a pinch of salt because the test set's only been on for 20 minutes. It's short of the half hour it needs to be on. So we'll have a look at that. So it should be 277912. Yeah, but it might be wrong for the. It might be. It's 2779113, which is not more or less spot on. That's fine. But you've got to set it a funny way, and you've got to start with the 10.69. It's 10.695. There's 10.245, not 10.240, and then you've got another mixer to do as well. So we've got to start with those. But the trouble is, which adjustments where? You know, this is always the problem. I did have an in bits board somewhere, but you know, we did buy a scrap board out of a base station. We gave it away because I never thought I'd see one again. So we'll unclip that. I'm not bothered about the receiver at this stage. I can't remember whether the top unclips from this, or whether it's. I don't think it does it? It's you're expected to know. You're expected to know which one is which. You know what? I think we're going to have to take this off. I know it's full of wax, but it's so long since I've done one. I'm going to have to take it off and photograph it, I think. So I'll unplug the mic. We don't need that at this stage. I'm going to unsolder the speaker. I'm going to switch the soldering iron on actually. I'm going to unsolder the screen, and we'll take that off. My goodness, this has had some soldering in its time. Right, pause the video. Right, so now we've got it without its clothes on. So at least we can see where the crystals are, and we can see, not that we can see what the numbers are. Yeah, it's very difficult to think where any test points would be. So we've got to start looking at my notes, and we know that crystal 1 is 10.245. There's crystal 1. And by the looks of that, that doesn't have adjustment. Now, that crystal is which? 36 point. That's our receive one. So that is, oh, it's 10.24. It says 10.245 in the data. So there should be no reason that we can't just set the frequency just trying to think which one it is. L9, but which is L9 because we can't see what the numbers are because of the wax. That's L10. So yeah, we know that's the receive. That's deviation. I mean, most of these are VCO things, but L T1, that's going to be transmitter. T11, that is transmitter. Oh no, it's not, that's receive. That's receive, that's transmit. So our transmit lineup is transformer 1, transformer 2. Yeah, I bet that's transformer 2. Soon find out. Transformer 1, L7, L4. So that's all straightforwards. Receive is 10, 11, 12, 13 and 14. So that's going to be 10. That's 11, 12, 13, 14. And that supposed to be the detector. We've got some red herrings in here. That's 14. Well, that's receive. That's receive, all right. What T9? T9 is the noise blanker. It has a very complex noise blanking circuit which probably even works, but we won't be fiddling with that. Transformer 10. I don't know. I don't need to touch anything I don't know. Power meter, squelch, that is, I think that's going to be, yeah, that's the S meter. So what's T13? It's in the, here we go. Can we see? So that's L13, that lower one. So T12 and L13. So I was thinking that L9 is the frequency, and I just don't know which L9 is. So we can see that's T3, which is in the VC, that's the VCO buffer. That's T4, which is VCO mixer. You know what? It's going to be between these two. So it's not going to be ridiculous to find out which one it is. Right, we'll put the mic back in. So I was expecting that you've got to set the 10.24, you've got to set the 10.695, which is your receive IF reference, but it's not kind of like that. I say it's a long time since I did one. By the way, I've seen these do as little as 2.5 watts, so don't expect it to be super power. See if we can do better than the current power output. That would be nice. Right, I'm keying up. I'm going to see if we can set the frequency. So at the moment I've got 27.79. Now it's going to be different because I've got the screen off. So I'm doing this. In fact, I'll photograph it while the screen is off. We're going to have to touch this back up again later. I just want to verify what's what. I think that's going to be frequency. Or I'm wrong, because that's VCO. That's frequency. So what's the other one? Is that also frequency? No. That'll be the amount of... Oh, I can see that's affecting power. So that's frequency. So everything under this can is going to have to be readjusted. So I'll now go to the power meter. And we'll bring that up. It's actually now 3.3 with the lid off. Now, which one did we say was the buffer? T3. Being very careful with that one. So 3.4 watts. That is broken, but it is moving. .6 watts. .6 watts. That's it. So there we are. That's so it's on a par with new sets, isn't it? And remember, the test set I'm using is a commercial test set. It's only reading the power which is on this kind of frequency band. If we use a hobby type meter, even the £90 hobby type meters, this radio will be doing more than 4 watts. A lot of people, when they get these back, they read the power and they're doing 5 of their watts, but they're doing 4 of ours. So, so never worry about what I say on power, unless I tell you it's 2.7 and it is a bit less. So that's that, and it's now on frequency till I put that lid back on. So we'll just check deviation. Wallow. 1 2 1 2 1. Just needs to come down a little fraction. It's peaking at 2.6. So that's deviation. Wallow. God grief, it's gone the opposite way now. Wallow. 1 2 wallow. Wallow. That's right. So we've done frequency, we've done the transmit lineup, so we're there with that. Now we'll turn our attention to receive, and the whole thing here is it being on frequency. So I'm going to set the clarifier to the central position. The clarifier is a delta tune. In other markets, they're going to do for the American market, they'd be doing an AMSSB version of this, and I think that's kind of just a silly word left over from a front panel of a different model, but it is a delta tune. So we've got that set to center, and what we need to do is to get a second signal generator set up. So we've got, this is what we're doing. This is why I've set the transmit, and I'm going to just recheck that we've still got transmit where I want it, because it's going to affect receive. So I've got 27, 7, 9, 1, 2, 3, 4. I just want this to be absolutely spot on. I do need to readjust it, as I said. Otherwise the delta tune won't be central. So there we are, 27, 7, 9, 1, 2, 5. So we've got that, and we'll connect our speaker back up. So we can actually hear it, and now we'll get a second signal generator set up on 10.695. You can hear how it's affected it immediately. So we've got 10.695 on this, unmodulated. I don't think this even does modulation. And now we're going to adjust the receive frequency trimmer Now that snag there was I'd got the tone still on the main signal generator. So let's be clear with this. I'll disconnect it. I'll put the tone back on the signal generator. Turn the signal down a bit. So I've got 10 microvolts going in because the sets. See if we can do 3. Yeah, we can do 3 microvolts. So I'm now going to connect my flying lead to this at 10.695. Turn the tone off, and as I adjust this, you're setting it for null when there's no musical note at all. That's how it's done. So we now, let's go through what we're doing. We've got 27.79125 on the main signal generator. We've got 10.695 on this signal generator. We could also do it with 455. That would also work. But we're doing 10.695 because it's easier. and the only both of those are spot on, which they are, the only variable is now this mixer crystal. So you know both the signal generators are right, so only the radio can be wrong. So that's what that's about. So we're using it as what's known as a marker oscillator. So that is the receive frequency set. Now we're going to have to check that again when I've put the lid back on, and I'll do that with you. So this is why I've had to take the lid off. We've got some other ones to do. We've got a Telecoms TC9000 here. We've got a Grandstand Gemini, and I'll do these in the next few weeks so that I can put away the information once again. I don't want to do them consecutively, you'll be bored with the same kind of sets. So with the tone back on the signal generator, we'll have a look at the synod meter. And with it on frequency, let's see what we're now getting as a synod reading. So we're now getting we're getting 4.4 microvolts, which is actually worse. Isn't that interesting? Now then, we start with, I'm going to start with T10. So I'm guessing it's this one, unless we can scrape away a bit of wax. You know what? I would have been wrong, because that's T7. And T7 is VCO, so we didn't want to adjust that. And I'm going to just check it's not affecting receive very carefully. It is actually, because it wasn't set right. So we're still looking for T10. We may never find it. So that's a T10. Right, so we're going to have the synod such that we're about 4 dB. Which is now, that's now peak. So 11. That was miles out, absolutely miles out. Good. That's got a broken core, but it is movable. So T10, T11, T12 next. T12 is that one. That was spot on. T13. Just put a bigger signal on for that. Put a smaller signal on. Yeah, it's there. And then finally T14. I'm going to do it. Yeah, this is L14, that's T14, so that's T14's the detector. So I'm going to do it on here first, and then we'll set up another oscilloscope for the demonstration. So I'm going to put an S9 equivalent signal of 100 microvolts on. Turn the volume up a little bit. It's not very pronounced on this. It's actually there. Just out of interest, I'll see what L14 does, because that's doing the shape. So it's between the two of them. Yeah, so with T14, it's kind of doing the shape of the recovered audio, and then L14 is actually the detector. Amplitude. I've got L14. T14's IF. What a silly billy. That's why it's doing shape. So the detector's L14. Right. So what I'm going to do is I'm going to set that little oscilloscope up so you can all see what I'm doing. So pause the video. Right, we'll switch picture in picture off. So this is a cheap oscilloscope kit. We bought it with the case. JYE Tech DSO. So these don't have a battery in them, they're external power, and it is 9 volts. So we've got a regulated mains adapter, not some unregulated one. So that's set to 9 volts. I think that oscilloscope kit was $16.99 from AliExpress. We went to the radio club with it and Mr. Chippy assembled it in a 1-hour session. So switch that on. And I'm showing this simply to show it doesn't get any cheaper and nastier than this. That's what I'm showing. We use the oscilloscope. You can see, if I'll tell you what, I'm going to switch. This is all go out of focus and horrible, but I'm going to just switch to a different view. So we're just going to zoom out from there. I'll just move the camera across. We've got two. I'll just get the kind of in the centre there. ST16C 10 meg oscilloscopes. Kind of get the light on it a little bit. So we use one for the detector and we use one for transmitted audio. So you see I'm not messing about with the adjustments on the scopes. These were 2 years ago about £110 each delivered. They're dead cheap, 3-inch round screen oscilloscopes, as cheap can be. And I got those because I particularly want to have CRT oscilloscopes on here because of the quicker response. I don't like latency from digital instruments. So you have seen me use the expensive. I'll just go back to our normal camera there. You've seen me use this. I think these are about 600 quid. MP7200-15, which is a 60 meg portable oscilloscope with a battery in it. So that's expensive. But this is something a hobbyist can buy. So I'm showing you these different oscilloscopes because any old thing will do as long as it works. So all we're going to... Oh, I've gone and disconnected the power instead of connecting up the probe. We ordered a probe at the same time, which is going to be as cheap as cheap chips go. So we'll connect the... We'll disconnect what we've been using and we'll use this instead. I'm going to put that back on because our speaker was on it. I bet the probe was as much as the oscilloscope. So plug that into the input socket. Well, that's not the nicest trace in the world. That's a bit noisy. I don't know why it's noisy. Let's try an ordinary. I'll just dispense with the probe. And just use an ordinary crocodile clip lead with the blooming things snapped off. Put that one to earth and hold the broken one. No, it's not the cleanest trace in the world at all, that. Right, we'll go back to the oscilloscope lead. I was beginning to think it was this, and it isn't. It's the actual little scope. I've got another one of these. I just wonder if our demonstration crap scope is worse than our other demonstration crap scope. Well, all I can say is that doesn't seem to be very reliable at all. Right, we'll go back to the other one. So I'm going to turn down the voltage division. There we are. I've put more volume on the set, and it's doing that fine. So hopefully we can see that, because I can't see the monitor very well. So once again, I'll adjust the detector. So with our dead cheap oscilloscope connected up, look, it's disappeared. See how easily we can set that up. Even with an oscilloscope as cheap and nasty as this. So there we go, that is your demonstration. I don't need to readjust it on the proper gear because it's reading exactly the same. And we can switch to that by putting picture in picture on. Which hopefully, I'll have to stand up to see the monitor. Ah, we need to return that to its normal position, don't we? There you go. And just to prove it, we'll adjust it again. It's not it's not really flickering much on the actual this oscilloscope. It's because of the camera. With it being an electronic display, the CRT oscilloscope isn't affected like that. So there we go. Detector. Worse, better, past the peak. So I just find it easier to use the CRT one. So there you go. That's just connected across the extension speaker socket. So we'll disconnect that. And I will put this back in the box it lives in. So the other part of the discussion was extension speakers. So this is the Palmer version of the SW711 that we usually use. These come up sometimes for a tenner on eBay. I think Palmer left the scene about 10 years plus ago. So it's one of these, comes with a bit of a mounting bracket. It comes with figure 8 lead and a 3.5mm jack, and at least you can, with figure 8 type lead, you can put a different plug on easily. And it says it reckons it's 10 watts. Well, I don't believe that, but anyway, it is 8 ohms. Now some of these have got a switch on top. They're a different model, and it says noise filter. You need to be linking that out because the switch is unreliable, and it isn't. All it is a noise filter. It puts a small electrolytic capacitor across, and it just reduces the treble. So with AM, it may make a difference, but it won't make any difference whatsoever on FM, apart from make it cut the treble a bit. So two versions, but this is the one without the switch is the better one. So it's the other one, the Charman's Wholesale SW711, is the one we tend to use, probably because we were dealing with Charman's Wholesale. But we were also, when I was at Nottingham Radio, we were dealing with Palmer as well. So a little bracket with those. But when Tandis did them, I think they were, could have been as much as 14 quid, but there's a realistic version as well. There's also a realistic version with a built-in 10-watt amplifier, the amplified speaker. We use those quite a lot because we may... Mr. Chippy's got one of those Yaesu FT790s and one of those 290s, which are those transportable 2-watt multi-mode sets from a bygone era, and they're only low output audio, so if you want to use them in the car, you'll use the not only an extension speaker but an amplified extension speaker. So I'll just put this back. Now if you see the Pi or Philips version of those, they're 3 ohms, so they're to be avoided because you'll overload the audio amplifier on a CB because they're looking at an 8 ohm load. So I think we're there. So all we need to do with this is to make sure that all the power reading display things are where they should be. So at the moment we've got an S9 signal on the radio. No, we haven't. We have now. And we should be getting S9, but it says plus 30, so we'll just drop that one. There we go. Now if I increase my signal on the signal generator, we'll get plus 30, and if I reduce it, it should correspondingly go down. So you've got 5 bars which actually are separate, not 10 pretend bars which are really 5. On transmit, just turn the volume down. On transmit, it's got the full 4, and we know the radio is doing 3.6 or something like that. So we still set it to 4. I just want to make sure that it's set right, because that wasn't. So I just want it to just touch the 4, because it was well into the 4. Now if I turn the power supply down, which I'm going to do to 12.6 volts, this radio is no longer going to be doing 3.6 watts. it's actually doing 3 watts dead. So the meter has gone down a bar, so that shows us doing that. That's good. And they're back to the 13.8 volts. I'm not going to wind the power up anymore because the power supply power, it's possible that it may do 4 watts at something like 14 volts. Yeah, it's not my set to do that to. So that's that. We've done the deviation, and that just leaves us with the squelch preset. So here goes, squelch preset. Squelch at full, 100 microvolts. I want the squelch to open. It doesn't. And it opens at 1 millivolt, so it's a bit too vicious. There's the squelch preset. It's now opening at 100 microvolts, which is where I want it to be. Now we'll just check squelch sensitivity. And the squelch sensitivity, we're going to turn the signal generator down. I'll put the attenuator controls on the inset picture so you can see where we are. So we're at 0.3 of a microvolt, and the signal generator has now been put to standby. That's what the red light shows. So we'll turn the squelch down on the radio. Set threshold. And then switch the signal generator back on. Well, that didn't work. We'll try again. Set threshold. Switch the signal generator on. I'll tell you what, the squelch isn't very sensitive. With a very wide hysteresis, it will track your signal, but the triggers very slow. Let's see when it comes in. So I'm at 0.4 of a microvolt, 0.5, 0.6, 0.7, 0.8, 0.9, 1 microvolt. Change scales. This comes in at 1.4 microvolts. But it leaves us never. You have to reset the squelch a bit higher. Right, I've set the squelch a bit higher. So it's now coming in at 1.7 microvolts and leaving it 0.9. So it's a bit insensitive. In the real world, we'll see what that's like round Scratchy Corner. But it's got a reasonable hysteresis. Not going to. Shall we test? Yeah, let's test PA for a laugh. So we'll connect my workshop extension speaker to the crocodile clips. We'll put that to there, and the other one, believe it or not, to negative. Now you can put the plug in either way, for whether you want the extension speaker to come through on the PA speaker, or whether you want only the PA speaker to come through. So you put the plug in the way you want it. I'll just see whether I can just go on that lower one. I think I have. Oh no, I'm on the wrong one. That's PA speaker. You can go on both ways anyway, whether it disconnects the speaker or not, something like that. I'm probably telling you a load of bull. Let's see what the instruction says over that. So I think we're on the PA speaker. We'll switch to PA. And I would think that... Oh, we haven't got mic gain, so...
Testing 1 2, testing 1 2, 1 2 1 2 1.
You have no volume control over the PA speaker. Isn't that fantastic? Not. So what we'll now do is to put that shield plate back on. So with the screen plate back on, we now need to make sure that it's still on frequency. So that was only done for the demonstration. In reality, you would not be taking that cover off. It's just so I could take my photo and show you. So once again we'll need to put this back on. Where did I put the lead for it? We were messing with that little oscilloscope. Take the tone off the signal generator. There we go. So we'll just check that the signal generator is on frequency. And just put that on the signal generator. 2779125. We just need to trim that so that it's spot on. Make sure we've got the clarifier to center. So now when we adjust the clarifier off its central position, we know that it's spot on in the centre. Just move the radio back a bit. See, I've gone and disconnected something by moving the radio back. That's a real good demonstration. Okay. So we'll take that away again. Switch the tone back on the signal generator. Turn the volume down a bit. And we're just going to look at the sensitivity. We've not looked at that. So transmit sensitivity, we need to receive sensitivity. We'll start with that. Go over to the synod meter. So if you remember, we started with, oh, where have I put my notes? 4 point. It was ridiculously high anyway, wasn't it? So now it's 1 microvolt. So I've seen better. We've all seen better. I'll give you an exact figure. For 12 dB synod, it's 1.2 microvolts. I will just make sure that it's not anything which we have put this shield plate on that's affecting it. I've done my diagram. We need to check transmit frequency. I forgot about that. May end up having to get that signal generator back again. Oh, we haven't got the mic plugged in. By the way, it's now 12 noon. I started this at 9. This is 3 hours. So it's now a bit high, so we are going to have to fetch back the machine. Should have checked that first. There we go, 2779125. Turn the tone back off. Bring this little signal generator back. No, it's spot on, isn't it? No, it's spot on. That's interesting. So that didn't affect that. Signal generator back on. Just making sure ones in the vicinity haven't been affected. No, so that's where it is. It's 1.1 microvolts for 12 dB cyanide. So let's see how sensitive we can hear it down to. Well, the answer is 0.3 of a microvolt. Right, so dropping things on the floor again. So I think that's where we are with it. Oh, low power on transmit. We never checked that. It's not adjustable, but we'll just check it. So it's still 3.6-ish on transmit. Goes into low power. And it's 250 milliwatts. It's supposed to be 400 milliwatts. It's not adjustable, but that's fine. I'll go and scan that, and then we've got it in the computer, and we won't lose it like we keep doing. Right, lunch break. Right, so I've scanned that into my computer, so hopefully we won't have to take a can off when there's nothing which we need to change inside there, because it's a bit of a faff, as you can well imagine, but was the only way to go to find what we needed to do. So we've got a result. I have to put these away. So we'll do my Grandstand Gemini in the not too distant future, and we'll hopefully dig out a Telecom's TC9000 as well. So the only thing I really want to do is to check his mic. So I'll put my mic with my radio. I can't actually see a Telecom's TC9000, so there we are. Right, just check his mic. One, two, wallow. Now that's got higher gain, so we need to reduce it. Wallow. Still too high. Wallow. Still too high. Wallow. Still too high. We'll get there eventually. Wallow. That's it. Spot on. I'll just make sure it sounds something like on my hand portable Testing 1 2, testing 1 2 3 4 5. Testing 1 2.
1 2 1 2 1 2.
Right, that's it. When we do the on the air test, I don't think we're going to be able to go into an extension speaker, but I'll look into that. I haven't got any adapters we've ever made up for doing this. Something to do, isn't it? Right, so the lids are on with the 5 self-tapping screws that it came with. I don't know what size they are. Perhaps if somebody wants to research what they are, they can tell me. We would normally, if it was one of our sets, I would tap them for M3 and put normal screws in, but that's I really should be doing the self-tapper, shouldn't I, when they're what's original, because we do specialise in OEM repairs. So we're on channel 19. Let's turn the squelch down. 19, Roger. So we're not likely to get anybody on this. No doubt during the course of the afternoon it will speak to me. We'll do an on-the-air test later on with Mr. Chippy. So I hope you found that interesting. And at the same time as discussing extension speakers and detectors, we've done the Grandstand Gemini from 1981. I think they were £119.99. They're certainly an expensive set. And apart from those dry joints which you can get, and this one hasn't, they do work very well. But as I said at the beginning, if you're going to be hearing anybody who's using a dodgy radio, whether the deviation is too high or whether it's slightly off frequency, well, you're not going to receive them very well at all on this, because it will just filter them out. To be Norman Collier. Thank you for watching.